Hi, this is Abdul Muqeet, and today we're going to discuss the second lecture of data signal processing. In today's lecture, we're going to discuss about signals and systems and how we use basic operations on systems like flip, shift, and scaling. And we're also going to discuss some special signals. So, in the previous lecture, as we discussed that I give a brief note about what signal is, and just basically signal is anything that gives you information about something. And but it's a general definition, but in DSP it's a description of how parameters varies with another variable. So we have two types of basically we can represent signal into two ways, that is a continuous signal and discrete signal. And continuous signal we have like in continuous signal we have uh, infinite values or interval, and for discrete signal we have discrete values. So, and this is about the system signal, and let's discuss about the system. A system is basically a process to create output signal using an input signal. So we just so we have an input signal and we want a desired output from that. So we're going to make a system for that input signal so that we can get the desired output from that input signal. So let's see the basic operations of we can apply on the signals. The first one is flip. Also, flip is basically we're going to flip the signal over the time interval, also known as it's also known as time reversal. Let's suppose we had a signal over here, x of n, and we want to flip it. So we're going to flip it by just making the negative interval. So let's suppose we had a signal over here, x of n. As you can see, at 1 we have 1, at 2 we have amplitude 2. So when we apply the flip operation, here you can see that it's a mirror, or a mirror of that signal is formed over here. So that's why we use the flip operation. Then the second operation is the shift. In this we shift the signal. Maybe it can be a left shift or a right shift. They have different lights. It's advanced shift and delay shift. In advanced shift we we take the output, we take the values in advance. Like if we want a value at 4, we're going to, if we want a value, if there's a value at 4, we are shifting, we are using the shifting property. We're going to get that value at 0 in this case. And similarly we have the delay shift. In delay shift we can delay the signal, we can get the value at a delayed time. So if the value exists at, let's suppose, 4, and we have shifted it like this and -4, then we're going to get that value which was first present at 0, we're going to get that value at 4. Here you can see that we had a signal over here, x of t. We had signal, and you can see that it's from 0 to 2. But when we advance shifted it, we are going to get the value which was present at 2 at -2. Similarly, if we want a delayed output, then as you can see over here, we are using a delayed shift. The value which we could have got at 0, now we are getting at 2, and the value which we could have get at 2, we are now getting at 4. So there's a delay of 2. So then let's talk about scaling. There are two types of scaling basically, when downscaling and upscaling. In scaling, what we do is either we shrink the signal or we expand the signal. In downscaling we actually shrink our signal. Let's suppose we have an x of n, Then to shrink it, we're going to multiply it with the number that we want, with the interval that we want to shrink it. A can be any number, 1 2 3 4, so on. And similarly, upscaling is we add up some extra samples. So basically we are expanding in upscaling, we are expanding our signal. So let's take an example. Let's suppose we have the signal over here, x of n. As you can see, the values are distributed over these intervals. So if we want to compress our signal, we want to take less values on the interval. Let's suppose we are compressing by the factor 2. So values are going to compress themselves by the factor 2. As you can see, there is 6, but now they are existing in 3 2 1 0 minus 1 minus 2 and 3, although they were existing at 4 5 6 as well. So we have basically, what we have done over here, we have shrinked our signal. And similarly, for expanding our signal, for upscaling, we use n by 2. So here you can see we have expanded our signal. As you can see, there was no value over 0.5, but now we are also getting a value at 0.5. And similarly, we didn't had a value on 1.5, but we are getting the value on 1.5. So then if we have a combined effect, let's say we have a signal in which and we want output which is shifted, flipped and scaled as well. So when this situation comes, there's there's a pattern, there's a sequence you have to follow to get the right output. And that sequence is, let's suppose we want this, that is x of minus 2 and plus 2. Here we are also shifting, we are also flipping, and we are also scaling. But we have to follow this following sequence is, first we have to shift that signal, the x of n, the signal will be provided. We have to first shift it, then we have to flip it, and then at the end we have to scale. Let's suppose y of n is equals to x of minus 2 and plus 2. So first we're going to apply the shift, which is of plus 2. First we're going to find x of n plus 2. We call it Zn. Then when we get the new signal, the shifted signal, we're going to flip it. Since we are flipping it, minus n, so we're going to flip it, z of minus n. We're going to call it wn. Then the shifted and flipped signal. Now we have gotten the shifted as well as flipped signal. Now we're going to scale it. So for scaling here, the 2 is the factor for scaling. I'm going to multiply it with 2. So then we're going to get the y of n. So that was those were some of the operations we can apply to signals. Now let's talk about some special signals. We have in signals and systems, we have some special signals. Today I'm going to discuss only 2 of them. That is the unit impulse. First one is the unit impulse signal. A unit impulse signal is a signal that exists only at the 0 interval. Its value is unity at 0. As you can see, its value is 1 at sample 0, otherwise it's always 0. That's a unit impulse signal. And the second special one we're going to discuss over here is the unit step function. Unit step function, or basically unit step signals, unit step signal is a signal that exists for the values for the interval equal and greater than 0. So the value the unit in unit step signal, the signal has one amplitude for the interval and greater or equal to 0. Here you can see that from 0 to there we have the signal, and we can also convert them. For example, we can generate unit step from unit impulse by using the formula this. So that was all today from my side. I hope you guys learned something from it. Thank you. We'll meet in the next lecture.